In this video, we're going to work through some challenge problems with exponents, meaning problems that are a little bit more difficult. They involve more steps, and then later on, we're going to look at some word problems as well. So let's take this example: 5 plus 3 times 2, all raised to the second power, and then all this will be divided by 4. So let's rewrite PEMDAS here. So we're going to look for parentheses, and it looks like there is some. And then we're going to evaluate PEMDAS within the parentheses. So it looks like there's no more parentheses within the parentheses. And then let's look for exponents. Notice there is an exponent here, but it's not inside the parentheses. When we're evaluating parentheses, we're only looking for operations within the parentheses themselves. So we're going to ignore this 2 for now. And then we'll move on to multiplication and division, and there is a multiplication here. So we can rewrite this expression as 5 plus 6, since 3 times 2 is 6. And this parentheses is still being raised to the second power and being divided by 4. So this will be 5 plus 6 is 11. And 11 is being raised to the second power and being divided by 4. And then 11 squared, or 11 to the second power, is 121, since 11 times 11 is 121. And all of this is being divided by 4. So our answer here, let's do this. 4 into 121. Let's see. 4 goes into 1 0 times. 4 goes into 12 3 times. And then we will subtract. So 4 goes into 12 3 times. And this will be 0. And we will drop down this 1. 4 goes into 1 0 times. But let's evaluate this as a decimal. So we'll add a decimal. Sorry. Add a decimal in the wrong place. We'll add a decimal here. Remember, we got to subtract 0 from this. So that will leave us with still a 1, and then we're dropping down this 0 here, and that will be 0. And then 4 goes into 10 2 times. 4 goes into 10 2 times. So this will be 8, and then we're subtracting that. This will leave us with 2, and then we add one more 0. And then 4 goes into 20 5 times. So our answer to this problem is 30.25. And we could have left it as remainder, 30 and remainder of 1, but I evaluated it as a decimal. So our answer here is 30.25, or 30 and 25 hundredths. Now we are given this expression. So we are given that 7 is being added to the expression 6 times 3 minus 4, and then all of this is being divided by 2 squared, or 2 to the power of 2. So let's remember exactly what a fraction means. This means that we're going to divide all of the numerator here by all of the denominator. So this is just going to be, and let's rewrite this with parentheses. So we'll write both the numerator and denominator in parentheses. So I'll have 7 plus, and then we have more parentheses here, 6 times 3 minus 4. Remember, this is one parenthesis and this is another, so we have to add 2 parentheses here. And this is all being divided by 2 squared. 2 squared. So let's start with PEMDAS. So we are going to look for parentheses first. We're going to look for parentheses first. And it looks like there is parentheses starting here and then ending here. And now we're going to look for parentheses within these parentheses, and it looks like there is also parentheses within the first set of parentheses here. And now we're going to continue with PEMDAS inside of this parenthesis expression. So there's no more parentheses, there's no exponents, but there is multiplication. So we can rewrite 6 times 3 as 18, and then it's still subtracting 4. Remember, we're adding all of this to 7. And then dividing it by 2 squared. And now we're still inside this parenthesis here. And there's no multiplication or division, but there is subtraction. So again, we're going to rewrite this. We will rewrite this as 7 plus, and we can get rid of the parentheses since there's only going to be one value now, 14. And then this is still being divided by 2 squared. And now there's still parentheses here, so we're going to do this before moving on to this expression. So 7 plus 14 is 21, and since there's only one value, we don't need to keep the parentheses. So 21 divided by 2 squared. So there's no more parentheses, but there is an exponent here. There is an exponent there. So this can be 21 divided by 2 squared is the same thing as 4. And then we can just rewrite this as, this will be 21 over 4, or let's see here, this will be 5.25. 5.25. And these are our answers to this problem. Now let's do this problem. So we are told that a rectangle's length and width is given below, and we want to know the area of the rectangle. So we want to know the area of the rectangle. We know that the equation for the area of a rectangle, we can rewrite this as area is equal to length times width. And we are given both the length and width, so we can write an expression that will give us the area. So we are told here that, see, this is the length here is 2 plus 3 squared, and the width is 5 divided by 1 plus 4. So we can just multiply these expressions together, and that will give us the area. So we will have 2 plus 3 squared times 5 divided by 1 and then plus 4. So we can use order of operations to evaluate this expression. So here we have parentheses, and then we're going to look for parentheses in the parentheses, and there is none, but there is an exponent. So we can rewrite this as 2 plus 9 times all of this. And then this will be 11 times 5 divided by 1 plus 4. There's no parentheses within these parentheses, nor is there an exponent, but there is multiplication or division. There is a division here. And we know any number divided by 1 is just going to be itself, so we can rewrite this as 11 times 5 plus 4, since 5 divided by 1 is just 5. And this will be 11. This will be 11 times 9, since 5 plus 4 is 9. And then 11 times 9 is 99. So our answer, this gives us the area in general units. So the area of the rectangle is 99 units squared. Now let's solve this word problem. So this word problem tells us that Tom bought 6 packs of pencils. Each pack has 8 pencils. He then used 10 pencils and bought 2 more packs, each with 5 pencils. How many pencils does Tom have now? So when given word problems like this involving order of operations, it's best to find an expression that the question is giving us. So first, let's see. Tom bought 6 packs of pencils. Each pack had 8 pencils. So to figure out how many pencils he bought originally, this can be given by the expression 6 times 8. So this is the original amount of pencils that he had. He then used 10 pencils. So we're going to subtract 10 since 10 of the pencils will be used. And then he bought 2 more packs, each with 5 pencils. So after he uses 10, we will get 2 more packs, each with 5 pencils. This will be 2 times 5. 2 times 5. Okay, now we can solve this problem. So let's start with parentheses. So there's parentheses here, and then there's no parentheses inside these parentheses. There's no exponents, but there is multiplication. So we're going to evaluate this parentheses, and this will be 48. And we don't need to rewrite the parentheses since there's only one value. And we're subtracting 10 and then adding 2 times 5. And there's some more parentheses here. There's more parentheses there. Same thing as last time. No other parentheses, nor is there exponents, but there is multiplication. So we can rewrite this as 48 minus 10 plus 2 times 5 is 10. First of all, we see there's no exponents outside the parentheses, and there's no multiplication or division. So now we can start with addition and subtraction going left to right. So 48 minus 10 is 38. And then we're still adding 10, and then 38 plus 10 is just going to be 48 again. So our answer to this problem, how many pencils does Tom have now? He has 48 pencils. And we are done.